So thank you very much, Chris, for that wonderful talk. And hopefully there will be some interesting questions from all of you out there. But to get started, do any of you folks on the stage here have a question that you'd like to pose to Chris Impey?
Thanks for that great talk. Now, you were saying how difficult it is to map out the potential signs of life or of the elements that might make out life. But with modern technology, I mean, I'm just thinking, couldn't you just do massive sort of data mining of the various spectra? So is it possible to automatize some of the search? So what Google does for web searches, can we do the same thing for planetary exploration?
So it's a good question. Yes, but only at the level of finding planets. So with 0 planets detected before 1995 and now approaching 1,000, that we are harvesting planets easily. And indeed, the citizen science or the public can even get involved in that. And maybe there's a slightly less excitement in finding the 2000th planet than the 1000th planet. The trouble is that the next step of the game of finding life signs on a planet is very much harder. It's orders of magnitude harder than detecting the planet in the first place. So the example I showed of spectra of planet atmospheres, remember that this is the signature that's 100, I mean, I use an analogy. If the Earth is the size of Earth is the size of a soccer ball, you're looking for something that's a soccer ball 100,000 miles away that's next to a light source that's 1 billion times brighter. So it's very hard for telescopes to isolate that. And we're still 5 or 10 years away even from a facility that could do it. And in a sense, that's why the radio astronomers who search directly for intelligent life, feel they have a little advantage, because they already can do that, and they can do it better every year. So they haven't got detection though, so they spend a lot of time looking at noise.
Yeah, then the tuish tangin dress on there, tuwa delia, tuwa tangbut down the and you tuwa nibas nyamdu letido. Pena tuwa ni tepchil tanchan dhuru. That tuwa tangbut dosi. Pena ta cereba gitanda shimju che jangone hansam yetne manguch che retina ne. 아니 지대 시행된 다 심주체네 망부치 도되기도 안디 가수 그렇다 아니 점리 디강리 알링열 심주 차선 점마서 지대 시행된 아니 근데 심주체티 아니 믹스게 고버도 가르이 나세 저탄 붙대체 아니 딜레 온도 간라 아니 기시 다디 올토 니바데 투고에 가르스나 किसी चीज़ें शेंग कितने लिया अन्य ट्रोज नहीं भाई ना अन्य तेल लिया फिर ता अन्य तेल लिया फिर तो चाहिए कि अन्य थबलम डबूता अन्य कंधे डबूचिए ना आस छेछे डबूए ना अन्य तेल फिर तो चाहिए अन्य गरा जो जंबुलिंगी अन्य किधर से सोला अन्य कर्जु गुरे से डबूचिते रिश्ता
So I've got 2 questions, and these 2 questions are interrelated. So first question is that so far scientists had made so many great achievements, and one of these achievements is about finding other planets. So my question is that since there are so many things that is yet to know about our own planet, why scientists are so interested in looking for other planets in other solar systems or other part of the universe? And that's the first part of the question. And somehow we are able to find a planet with lives on it. And when we find that planet, do we have any plans, or do scientists have any plans to benefit those sentient beings on that other planet? And by helping or benefiting those sentient beings on the other planet, how we, the people on Earth, will going to benefit from that kind of program?
Okay. Yeah, great questions. For the first one, why do we do this when we have plenty of problems on the Earth and plenty we don't know about our own planet? Part of the question is very simple. It's just pure curiosity, that we look beyond ourselves and we look beyond our immediate situation. I guess the analogy I would use is the way humans spread across the Earth 50 to 100,000 years ago. Humans, less than 1 million, coming from Africa, within very short time, hundreds of generations, spread across Asia, through the Americas to the part of South America. They didn't have to do that. It would have been more comfortable not to, if they cared about comfort. For example, on the way from Siberia to Patagonia, they passed through Southern California. Why didn't they just stay there? So I think, we are curious. That curiosity is built into our DNA, and some part of that we use to express outwards. Would be bad if it was all of it. Another answer, scientific, practical answer, is that it's sometimes easier to look out than in. The deepest hole we've ever dug in the Earth is no deeper than the thickness of a skin on an apple. It's very hard to do better. So even learning about our own planet directly can be harder than looking out with a telescope. And then the other more philosophic reason I think we do it, when we have so many problems, or why it's not a bad thing to do, is it speaks to our cosmic situation. It tells us more about ourselves. If we're alone, unique, part of a tapestry of life elsewhere in the universe. And in the second question was, remind me the second question.
When we find those.
Yeah. And that gets to the second question. Because it's such a new science, not as much thought has been given to how we will behave or what we will do, but some thought. For example, this may surprise people, NASA has given a lot of thought to exploring the solar system and not contaminating it. Every mission that goes to Mars in future will be designed to not contaminate Mars and to clean up after itself, not even leaving debris. Of course, enormous protection is planned if we ever bring a Mars rock back to the Earth, in case the microbes that it might contain would hurt us. So there's a protection idea. There's another idea in the space community that there's a tension, of course, between two ideas. One, that space is there for us to take, as civilizations on the Earth traveled around the Earth and made empires. So we will take asteroids, take planets, take other planets. But there's a counter movement in the space community to not alter anything, to never alter a world that you find, to just look at it and learn without not just Mars, but somewhere else. So these ideas are now forming of how to protect and preserve and learn. And then, of course, there's a hope that we might learn something really substantial if we ever found a sentient, intelligent life form, something really important for us. How could they? It's unlikely they would know exactly what we know or feel what we feel. And fear should not govern us in this. It would be bad for us to just be afraid. Stephen Hawking has been very famous for saying we shouldn't say we're here with radio telescopes because they might come and destroy us. I don't agree with him. So.
다단당이 좋았어야 돼. 단다 당시 진행 그 소용되거나 나도 지팅 감디 나로라 네 세속은 페르면 나라 동부 소소 참으지네 단당아도 미 버터 페르면들이 좋아해서 디 나로네 나도 미 라바데 소속은 세속은 페르면 나니 네 체시직 쳐도 어린들이 지고서 지디가랑이 좋아가야서나 세속은 페르면 나니 미 라발리 네 미 라발리 체비 소소 잔다 네 요메스 네 영어지 세속은 페르면 나니 라바 총식의 소소대 강이나시 좋아다디
When we talk about evolution on this planet, on this earth, it is said that the living beings evolved from a single cell to the large mammals like us. And from evolution point of view, is there any living beings who has got more brain size than human beings?
More which?
Brain size.
Yeah.
Brain size. Larger brain size than human being, and which organism has the smallest brain size?
So I'm not a neuroscientist or for the history of it, but there are larger marine mammals, orcas and whales with bigger brains than ours, but brain function is not simply related to size, so that's a very hard thing to say. And brains have evolved over more than 500 million years. It took 500 million years or more for creatures to evolve those capabilities. So it's very hard to tell because people I know at my university work on intelligence of corvids, crows, and that you saw examples of, ravens, crows. And the neuroscientist there would tell you that a bird brain is a very efficient neurological package. And so size is not the determining, should never be the single determining feature. And then the distributed capability of an octopus, a cephalopod, is something we just don't understand. So more interesting to me is there could be other architectures for brains that we really don't know how to measure, and then size would be completely a poor measure of that. We'd have to figure everything out.
I appreciate your presentation. Very, very beautiful. But I do have some question like astrobiology is quite young science, field of science. And from that point of view, I think it could be very difficult to be sure that there is life out there. But you presented Fermi's equation. From the point of Fermi's equation, he appears to be at the side of there is surely a life there. So where are they? The question is very positive. It's not asking like, are there any life out there? So that's a very different question that is presented.
Yeah.
So what is the logic behind that?
So it does raise an important point that I will generalize, but I've talked to enough scientists to see that there's truth in the generalization. Life scientists tend to be much more pessimistic about the possibility of life elsewhere than physical scientists and astronomers. And I think that's simply because life scientists look at the many conditions that had to be satisfied apparently, the twists and turns in the path of evolution, the fact that life on Earth was simple for a very long time and took a long time to become complex and intelligent. And even then, intelligence exists in only a small number of species out of millions and millions. So they would say, all of those things say it's unlikely. So the people look at different sides of the coin. The astronomers say the ingredients are everywhere, the conditions are everywhere. On one planet, life radiates to every possible evolutionary niche, and some that are even hard to imagine. So if you give it another environment, it'll just do something different. And there's no way to win that argument. Science is empirical. You have to see, you have to go and look. So I think there's argument on both sides. I recognize the strength of each side, and that to me is the reason you have to look, however hard it is. And as for knowing for sure, you're right. The evidence for habitable planet is in our hands now. If out of the 700 exoplanets known, there are 50 that are habitable in traditional sense. We have habitable planets. Some are within 2 times Earth mass, close to Earth. That's going to happen. The saying they're habitable and saying they're habited is very much harder. So I was mentioning that that's an experiment that will take 10 or 20 years. But I think it will happen. There's much motivation to do it. There was a second part of your question that I forgot.
The thought is like, I was more kind of curious about how Fermi could be so
Fermi's, yeah.
kind of firm about his question. Like, if you say a question like, is there, then that could be more kind of relevant to a scientist.
Right.
But to say that, where are they? It doesn't
Yeah.
really look
Right.
like, from scientist's point of view, a question, you know.
It's a good comment. So, and to talk about it, you have to understand Fermi as a scientist was a very accomplished physicist, but provocative. He was a good teacher. One of his methods of teaching was to provoke students with questions that maybe should have an answer but don't, or questions that seem sensible but looked at deeper maybe aren't. And that, I suspect, was one of his questions, designed to provoke. Because he used the statistical argument of the physical scientists that with so many habitable worlds, one of them, something's got to be out there. You know, they can't all be dead. But it's true, they could all be dead. It's possible. And then where are they supposes that they also can travel, have spaceships, have telescopes, and that's a huge extra assumption. So I think he was not, he was doing this as his recreational science, not in his core science.
Okay.
He was being argumentative. And of course, it's proving a null is very hard in science. So that's a more philosophic problem.
Well, there are a large number of very interesting questions from you all. Thank you very much. And we'll try to get to several of them now. And also I want to remind you that this afternoon, the day will conclude with a panel discussion on the broader topic of cosmology and consciousness. And some of the questions which you asked speak in a very interesting way to that interface of are there connections between mind and cosmology that are relevant to this topic of astrobiology? So we may defer those questions till later today and ask a simpler one now. Like you mentioned at the beginning of your talk that even biologists can't agree on how to define life, but to the best extent possible, how would you define a living entity?
Right.
And are there any scientific laboratory studies now that are trying to create life or the basis for life in the laboratory, and maybe even doing that with elements that are not the standard ones, carbon, oxygen, nitrogen?
So the definition of life, Erwin Schrödinger, another very esteemed physicist of the 20th century, wrote a book, What is Life, in the 1940s. And he used a information thermodynamic argument that life is something that can harness order from the chaos of the natural environment and essentially store information and organize that information and propagate it. And then the last ingredient is evolution. You have to have a mechanism to evolve the information. And if you just call it information, that liberates you in some ways, because, you know, DNA and the genetic information of the human organism and all creatures on Earth is one genetic code. There are many possible genetic codes, and there are other ways to code information than macromolecules. So the theorists of the subject, theoretical biologists, a small breed, actually try and imagine very different bases for life. And the more extreme view, of course, is that life doesn't need biology at all, that you could have information organized in other ways, physically through electric, magnetic fields, other things. They sound like science fiction, but you know, science fiction is based on science too. So it's very much speculation, because we all just start with the thing we know. And in terms of the second question, the thing we know, can we tell the story of how we got here? It's very important to be able to tell that story scientifically. The answer is not yet, because the story is lost in the mists of time. The pathway from molecules with 20 or 30 atoms, which exist naturally on the early Earth. In fact, amino acids are in meteorites and simple fats and lipids. So there's some, you know, small molecules that are not trivial in extraterrestrial material. That was there at the beginning. There was a lot of energy, there was water. But can you take all those and get a cell? No, not in the lab. Miller and Urey did experiments in the 1950s. They've been updated, but they never reach anything like a replicating molecule. So a series of lab experiments in the last 2 decades have essentially taken pieces of the puzzle. I mean, if there's a linear path from big molecules to the simplest cell, we've paved with lab experiments, I don't know, maybe 20% of that road, 30%, because it's been shown how molecules can become more complex naturally on clay surfaces, say, which is a template for reproduction. It's been shown how oily material in water can naturally form protocells, much smaller than present-day cells, but that's okay. And that those cells will concentrate chemicals and increase the rate of reactions and naturally subdivide. And in this, I'm summarizing a lot of research very briefly, but in all the sum of those research experiments in the lab, you have the rudiments of how you would go from simple molecules to a chemical form of natural selection before you actually have what we would call a genome. And that last step is a very hard one and may not ever be done in the lab. And all these events took place on the Earth 4 billion years ago, and there's no evidence. There's essentially zero evidence remaining, because it's almost impossible to find rocks that old anyway, and the ones you do find are tortured by volcanism and heat and pressure. So there's no trace of what happened, and that's a problem. So this is a historical science. It's not an empirical science in the normal way.
Well, maybe time for one more question here. This is again kind of a big one, and it synthesizes questions from several of you. And that is, if there are believed to be so many potentially inhabitable worlds even in our own galaxy, and if there's been, of course, billions of years of evolutionary time available even before life started here on Earth, and the speculation that's kind of grounded in at least statistics that there may have been time for many advanced civilizations to develop and explore around, then is it possible that various phenomena that are often attributed kind of anecdotally to extraterrestrials here on Earth may in fact be actually that. And do astrobiologists and cosmologists interested in extraterrestrial life take those kinds of reports seriously?
Yeah, so it's an important question because we, in the popular media and culture particularly, there's widespread storytelling involving UFOs or alien visitations. And so the ironic situation is that while most astronomers might believe on these statistical grounds that there are likely to be intelligent civilizations somewhere in the galaxy, they equally well believe they haven't visited and they haven't been to us. And rebutting that belief system is, of course, I can't do it in a few minutes, and they couldn't even in an hour, because you cannot refute so many individual reports. But in general terms, Carl Sagan said extraordinary claims require extraordinary evidence. If scientists claim to find microbial life on another world, they will be held to a very high standard before it's believed. If anyone claims that intelligent aliens have visited the Earth, such a claim is held to similar high standard. And the essentially complete lack of physical evidence that can be analyzed in independent labs is the fatal flaw in the UFO case. Fatal. Photographs, forget it. Eyewitness reports, I'm sorry. Eyewitnesses are famously flawed, even if well-intentioned. So I won't discount all of those, but you have to put your effort where the most fruit lies, and following UFOs has not been a fruitful exercise for the scientists who've involved in it. And the other thing I would say is that there are many answers to this strangely posed question, where are they? The people who believe UFOs represent real visitations have that answer. Yes, they came here, they visited. Another answer, and maybe the most likely one, is that we are very isolated in time and space, that they exist but that they're rare. And in that case, if the distances were thousands of light years, these are very difficult chasms of space to overcome with technology, to scrutinize with a telescope, as we're finding ourselves now trying to do this. So the isolation aspect could really be significant, and may indeed be the case. And then the other answer is that they don't do this. They don't care. I mean, dolphins and orcas, I believe, are intelligent, are sentient, have emotional states. There's evidence, of course, that elephants are aware of their mortality, and some other species, and mourn their dead. But these creatures, as far as we know, even if they evolve, will not build radio telescopes and spacecraft, or telescopes of any kind. And that's no fault of their own, to be trapped in a marine environment and not do astronomy. And if the universe has creatures in it that are not able to do that, or don't need to, or live completely full lives without doing it, well, we won't know about them. There's even a cultural layer, not just the last part of the answer, is there's even a cultural layer you could place on this, which is that the business of very active exploration, which in the history of the world has been twinned with colonization and some very bad things, the exploration of space, which in our culture had its genesis in a bitter superpower rivalry between the United States and the Soviet Union, in which lots of weapons were involved, that this landscape of exploration and of projective exploration into space is a very Western, mode of operating. And maybe if the world had a dominant Buddhist culture in the mid-20th century, none of that would have happened. Maybe we wouldn't have had a space program, and we'd have taken care of business on Earth, and and maybe other creatures elsewhere are doing the same thing, and so we don't know they're there.
Great answer. Yeah. Well, thank you everyone for your participation this morning.